Hello and welcome to today's SAS webinar, Automating Analytics with Artificial Intelligence. I'm David Stevenson from SAS. Let's meet today's presenters. Pat Richards is a big data expert at Intel, currently leading the SAS-Intel Alliance relationship. His expertise in artificial intelligence and machine learning has made him a respected speaker and contributor on the subjects. He previously led Intel's Big Data Service Enablement Organization in the Southeast, helping companies implement and realize true business value with big data solutions. And Beth Ainsworth is an AI and language analytics strategist at SAS. She's responsible for the global SAS messaging of artificial intelligence and text analytics. Prior to SAS, she spent her career as an intelligence analyst and senior instructor in the U.S. Department of Defense and Intelligence Community, primarily supporting expeditionary units and special operations. Welcome to both of you, and Beth, I will turn it over to you now.
All right, thank you. Good afternoon, everyone. Today we're going to talk about SAS's perspective on artificial intelligence and review some of the case studies that we've done and just provide a high-level overview on what artificial intelligence is and how we define it and how it can be useful for you. Okay. So I like to always start AI presentations with a quote on leadership. And Colin Powell said, "Great leaders are almost always great simplifiers who can cut through argument, debate, and doubt to offer a solution that everybody can understand." And when it comes to artificial intelligence, it's really important that we simplify it so that all of our investors, all of the stakeholders understand what artificial intelligence is, how we're trying to use it, and that also our customers can understand what it is and how we're trying to use it and the impact that it can make. The great leaders become great by balancing strategy with tactics, future vision with the current reality, and strength with weaknesses, all with the end goal of accomplishing a clearly defined objective. And great leaders also understand that people are the most valuable resource that an organization has. And to drive and inspire success, it's important to leverage a team's strengths while recognizing their inherent weaknesses. And with many of our human experiences and interactions involving a machine, today it's time to learn how we can evaluate how we can better leverage the strengths of machines while acknowledging their weaknesses to augment our ability to understand and improve the world around us. So we're talking about being able to integrate the strengths of machines with human strengths to help us achieve our objectives. Recent advances in machine learning, they've allowed us to create computers that can see and hear and speak to us in seemingly very human ways. Machines can learn and understand and make assessments about the world around it based on the information that we provide. So we've evolved past the time of telling machines what to do with our data to an era where the machine can learn from patterns and anomalies that it finds in the data on its own. Patterns and anomalies that our human minds can't find due to the sheer size of and complex intricacies that exist within the data. So the machine's strength lies in the ability to reliably, efficiently, and accurately analyze very large volumes of data without fatigue. But the computer doesn't understand strategy, so it's limited to a specific task, but it does execute that task in a very intelligent manner. And ability for the machine to learn and provide insights is limited in scope. It's still up to us as humans to take those insights and determine what role that intelligence is going to play in our strategy to accomplish that clearly defined objective. And the idea is that if we can harness the strengths while acknowledging the weaknesses of machines and artificial intelligence, that we can use the current reality of where technology is today to achieve a future vision of success. So the next question is, what is artificial intelligence and what is the current reality? So simply put, artificial intelligence is the science of training computers to perform tasks that typically require human intelligence to complete. So the machine can learn from data that is provided by identifying patterns and relationships that are present. The machine ingests massive amounts of information. It extracts key features. determines the best method to analyze that data, and then the next step is that the machine writes the code itself to execute that analysis. And it produces an intelligent output all through an automated process. And this all happens with minimal human intervention, but requires substantial influence from the machine's human counterpart. So let's look at an example where artificial intelligence can provide new insights through performance analysis in sport. How we can move from statistical measures of success to evaluate player intuition and decision-making under pressure. So for each of these case study slides, you will see 3 segments of text on the screen, and the top one is the goal. What is the goal that we're trying to accomplish? The center text box is going to be what is the strategy, how do we plan to accomplish that goal? And then the very bottom is going to show what tactic we used, where we started in this bigger plan. So the goal here is to use analytics to determine the influence of individual players on team results, to track player development, determine potential market for a player, and predict game results. The strategy is to extract those real-time insights during the game. And we do that by lining a field with cameras and capturing the footage in real time and allowing artificial intelligence to be applied in assessing those player movements. But you can't, that's the plan for how you're going to reach that goal. But it takes very measured steps to get there. So if we use player identification as a starting point, the machine is presented with many photos of different jerseys to learn simply which names are associated with which uniforms and which player numbers. That process begins by using still images to train the computer. Once the machine has learned how to process those images, the next step is to automate that process and increase the scale of the application. So what that really means is that the computer can see player 15 in a red jersey with a given logo and identify that player with the same speed and accuracy that we can as fans watching the game. The machine can also have that same speed and accuracy in simultaneously identifying every other player on the field. But that's just the starting point. It's the tactical step in a greater strategy to achieve that goal of more in-depth performance assessment. Further development will allow the computer to move beyond simply classifying the team and the individual player, using object detection to identify the position of both the player and the ball on the field and determine things like how fast does the player run, how high do they jump. And all of that can be assessed with artificial intelligence. That data can then be used to identify rising stars or undervalued players by simply benchmarking their performance against others in a league. But to achieve that level of analysis and insight, we have to understand the path that it takes to get from image recognition of player jerseys to object detection of player and ball position on the field. Then we further have to enable the machine to analyze complex performance assessments. Things like when is aggression a good thing, or when does intuition separate the good players from the great. And all of that requires significant data and human expertise to teach the machine the task it needs to perform to help us reach that objective. So here are some strategic applications of artificial intelligence. So that was a case study on one application. It's important to note that none of these capabilities are purchased out of the box. Visions and objectives aren't cookie cutters, so AI applications shouldn't be either. Understanding the end goal is paramount to laying a strong foundation on which these applications can be built. So there is a need to consider things like large amounts of data are required to train the machine. Where is that data? How are you going to access it? And how do you know that you're collecting the right data? You need increased compute power, data scientist skill sets, and industry domain expertise to influence the development, the function, and the purpose of the applications. So yes, AI enables the machine to give us insight from data that we haven't discovered, but before it can get to that point, it requires human direction and expertise to design that task that the machine is expected to perform. So where do we start in that design? So the foundational skills that a machine needs to learn from data and produce an output, they're not new. Machine learning is not new. SAS has been a pioneer in machine learning for more than 40 years, so our foundation is strong and stable. And the combination of constantly growing data and significantly increased compute power have extended those foundational skills of machine learning to create a deeper aptitude for learning. Now we have the ability to ingest bigger data and run bigger models with better algorithms. And machines can continuously analyze substantial amounts of information and transform what has been read or heard or observed into intelligent insights at a tremendous operational scale. That deeper aptitude is what you will hear referred to as deep learning, and it's a key component of artificial intelligence. So what does that look like in action? So here's a case that we used in reference to the solar farm we had here in our SAS headquarters campus. And then the goal here was to improve energy forecasting. The strategy was that we used short and long-term variability to improve the accuracy, and deep learning is the element of artificial intelligence that we used to accomplish this. So better algorithms available through deep learning showed a 20% reduction in the error rate of solar energy farm forecasting than a more traditional forecasting method. And improving accuracy has very real impact. This allows the energy company to understand optimal energy consumption, like how much to buy from SAS, and predict times when the solar farm might not have as much available. So that data can be factored into an overall plan. So how was deep learning applied? In this case, data was gathered hourly and used to train a model. The model was trained on historical data and generated forecasts for later time periods that weren't used in the training. So for example, a forecast was generated for the next hour, and that forecasted value became input into the following hour's forecast. Because deep learning was able to capture the short and long-term variability in the data, using an algorithm capable of learning long-term dependencies, we were able to generate much more accurate forecasts than traditional forecasting models. If we go back to our foundation and talk about natural processing and understanding, natural language processing and understanding, that is the other side of the foundation to build an AI application. So to use the deep insights that artificial intelligence can produce, we have to teach the machine to understand, interact, and communicate with us in a very human way. What a machine can learn and comprehend and reason is useless if we can't understand the output or provide new input in a manner that is intuitive through language. So building on the foundational skills of natural language processing, which have long enabled us to intelligently process and analyze data, advances in machine learning have extended those capabilities to give us a stronger collaboration between human and machine. Machines can now chat with us through text and speech while constantly learning and gaining insights through each interactive experience that we have. They can also self-generate results of their analysis in the form of narrative summaries, detailing and explaining what they have learned from the information provided. So these communication capabilities also fall under the umbrella of text analytics, which are integral to the success of artificial intelligence. So let's look at what natural language understanding looks like in action. So in this case, we have a company that wants to look at using natural language understanding to ensure optimal costs are achieved through a company's purchasing organization. So the overall goal is to ensure supply chain stability. And they want to do that by improving their response time to changes in the market, using the element of natural language understanding to help accomplish that objective. So in order to achieve the goal of supply chain stability, the company must improve business functions to anticipate better and respond better to rapid and deep changes in both their internal and their external market. So what does their market look like? In this case, a team of 40 buyers are responsible for ensuring that more than 450 raw materials are available at all times across 20 plants and subcontracting locations. The team's also responsible for ensuring that the materials are procured optimally from over 300 vendors and factor in different events that would typically disrupt the supply chain. They've got to proactively manage commitments on material servicing, address situations arising out of weather events or trade-offs to make sure that they're making informed and optimal decisions. So using natural language understanding, the machine can help curate past decisions and use that to arrive at a relevant and meaningful insight in the context of the available information. So the insights can come from structured or unstructured sources, internal, external information, things like email, meeting minutes, chemical technology, social media. After the machine processes all those types of data, it can learn not just from the syntax of what is written, that's the natural language processing, but it can also understand the context, the meaning behind the language. That's natural language understanding. The system can learn what ideal decisions that the other purchasers have made in the past and look at what incoming data would impact similar decisions to be made at a current point in time. So we're talking about being able to use past behavior to predict future behavior and provide a recommendation by understanding the text that's coming in and the task that the human has to complete. So if we move back to how we build an AI application, we've talked about the building blocks, machine learning and natural language processing, the extension of those building blocks into key elements of deep learning and natural language understanding. And you can use those either together or independently to build AI capabilities. So think of these as the actual task that you're asking the machine to complete, whether it's pattern recognition, image recognition, speech to text, natural language interaction, or some of those narrative summaries like I spoke about in regards to natural language generation. So you use the building blocks independently or together to create one of these capabilities. And one of these capabilities will form one aspect of the application that you're seeking to create. So in this case, the capability is pattern recognition. That is the capability being used in this strategy to identify defects during production with the goal of optimizing the manufacturing process. And in this case, we're looking at semiconductor manufacturing. And there's a 1 in a billion failure rate for droplets. And it doesn't sound like a bad statistic, but when you consider that 50 million droplets are pushed per second, the defect rate is practically 1 every 20 seconds. So in this case, we train the machine to look at what a good wafer looks like as a starting point. A wafer is a thin slice of semiconductor material that's used in electronics for the fabrication of integrated circuits. And each wafer is defined by over 90,000 measurements. So we took data from images on what a good quality wafer looks like. It has a smooth surface and same pixel values. Deviations in base values make for an uneven surface, which is poor quality. So using image processing and pattern recognition, 40 patterns of defects were identified. And once they're known to the computer, that pattern detection technique can be used to match new wafers to the dictionary of defects, and in doing so, detect those bad wafers automatically. So if we come back, this is the SAS approach to AI. We've talked about the different elements on how it all comes together. You have the building blocks. You use your building blocks and your key elements of deep learning and natural language understanding to form a capability. And that capability goes into a larger objective, a larger application that's going to factor in what your business goal is and what you're trying to accomplish. So AI requires a vision to achieve, understanding how to leverage the elements and capabilities needed to build an AI system. It requires a strategy supported by very deliberate, measured steps to build the application that helps accomplish your unique objective. So we've talked through several business applications of AI, but here at SAS, we also believe in using our technology to give back through our Data for Good program. and recently worked with a group to reduce the impact of traditional tracking methods on wildlife conservation efforts. Endangered species are often monitored using invasive and costly approaches like radio telemetry, marking, ear notching, transponder fitting, and then like close observation from vehicles or air. So all of them involve disturbance or direct physical handling of the animal, and some methods actually cause long-term harm to the animal. So to reduce the negative impact, conservationists created a new technique to take photos of animal footprints and use the images to determine the population of a species in a given area. Each species has a different foot anatomy, and within each species, each individual has its own unique foot characteristics, similar to our fingerprints. In this case, experts, scientists, conservationists, took individual photos of wildlife footprints, and they analyzed them to determine what species and even gender of the species that the prints belong to. It's a very tedious process and required a lot of expert time to identify and classify the track. So using image recognition, SAS was able to ingest those images and automate that identification procedure. The original raw images were directly ingested into the machine, and the machine was able to complete feature extraction and classification automatically and simultaneously. Previously, experts would take photos with a ruler to show the footprint size, but the machine was able to get all of that information without the ruler present. That allowed for the process to move beyond just experts taking photos to empowering local citizens to take photos and provide more data. And the steps to automate the image collection process can further be supported by the use of drones to reduce human presence and impact to the environment. So now experts can use the time saved on the tedious process of manually classing footprints to gain a deeper understanding of wildlife numbers in an area and instead focus on new and existing conservation efforts. So artificial intelligence, it should not be a black box tool that operates separately from the rest of your analytic strategy. And that's why we've embedded artificial intelligence here at SAS into our SAS platform. It's not the correct solution to every problem, so understanding where, when, and how to apply these capabilities within a larger strategy requires expertise in both industry and analytics. When it comes to driving strategy, using the right tactic at the right time is essential to achieving success. And in terms of analytic strategy, at a very basic level, we at SAS believe that analytics should be applied to wherever there's data. And we're advancing analytics by embedding AI inside the SAS platform. And our platform is designed to support the end-to-end analytics lifecycle because we understand that a carefully designed and well-implemented analytics strategy can help organizations achieve more. There are going to be problem sets that are best solved by more traditional methods and others that are ideal for the application of artificial intelligence. A differentiator for SAS is the ability to combine traditional and modern machine learning methods in the same platform on the same data with an integrated security model. And so where we started, we talked about leadership and that great leaders become great by balancing strategy with tactics, a future vision with where we are today, and strengths with weaknesses in order to accomplish a clearly defined objective. And for our customers, we say that you understand your strategy and we understand analytics. We can guide on integrating advanced analytics, including artificial intelligence, into a broader strategy and help understand the strengths and weaknesses of various methods based on a desired outcome. We can apply practical real-world analytics on a clear path to help achieve your future vision. And so to close this out, we'd like to just leave you with a thought on what is your vision? What is it that you're trying to accomplish? And where can artificial intelligence help automate those tasks? At this point, I'm going to turn it over to Pat for his presentation.
Thank you, everyone. First, I want to talk about how we at Intel believe that AI is the next big wave in computing. And, our predictions are that we're going to see a 12x growth in the next 2 years of the use of AI applications. And this is due to the fact that right now we're looking at only about 7% of all servers are actually used for AI applications in the market. About 60% of those are for what is typically referred to as conventional machine learning, while the other 40% were used for deep learning. Now, At the 12x growth in the next 2 years, a lot of you are probably skeptical, as you should be, and we've seen that these kind of predictions before about the growth of AI in the 60s and the 80s, where both times where AI went through a renaissance, if you will, and was brought up as the next big thing, et cetera, and both times it kind of fizzled out. So why do we think it's different today? Basically, there are 3 things that are clearly driving that difference in our mind. One is the amount of data that we now have. Data is being produced at a rate that we've never seen before and provides us with a solid base on which to do these type of AI applications. Secondly, compute has risen to the capability to actually deal with the data at that volume. So we actually can now match both the data and the compute to the right level to accomplish all the applications and the promises that the AI and deep learning field have asked for. And because of that, it's led to an innovation surge right now, where we're seeing companies moving forward much more rapidly, actually applying AI in production, driving real business results from it at a rate and a success rate that we've never seen before. So that's what's driving this. And there's been some research by various people who now believe that most corporations, if they don't adopt an AI strategy, will find themselves dramatically behind in their markets of choice going forward. About the data deluge, and this slide really brings that to home. If you look at the volume of traffic and data we expect things to be generating by the year 2020. So every one of you out there, we expect will generate about 1.5 gigabytes of traffic on the internet a day by the year 2020. If you look specifically at self-driving cars, generating 4 terabytes per day of data each. From various systems that are kind of broken down to the right, et cetera. Now, obviously, this amount of data is intimidating. We won't keep all of it. We'll be, much smarter about how we deal with time series information, et cetera. But we're going to rely on AI systems at the edge to tell us which data is important and which data that we need to move forward with. So, we also believe that AI is absolutely going to issue in a better world, allowing us to accelerate large-scale solutions to do things like curing diseases by allowing, the detailed examination of molecular biological type data, unlocking dark data, which is the idea of all the unformatted data that's in many, many places that companies don't have access. There was a study done, for example, of medical records, and your patient records, the amount of data that's actually in machine understandable and readable form without applying AI technologies is approximately 20%. 80% of the rest of the information is in things like doctor's notes and nurses' notes, et cetera, and that's critical information in most cases that's needed to deal with medical conditions. It's also going to unleash a new level of scientific discovery, again, as we can process the data, have the machines do the grunt work of isolating on the areas that are actually interesting about what's going on. And frankly, they have the advantage of not coming in with preconceived ideas about what's important and what's not important, right? They literally find those things that are important. Extending all of our individual capabilities by personalizing learning, the use of virtual reality type environments to help us enhance decisions by providing additional data and information points across the world is undoubtable. And then the whole idea of automation that can be applied by AI that we haven't seen before. Obviously, the thing that's getting a lot of the press around that type of automation today is automated driving, but it's also automating, as we were talking about earlier, and looking at chip production, identifying the flaws in the chips and isolating the causes of them and moving that forward. So there's a tremendous amount of new applications in which AI can be applied against. Obviously, I'm not going to go over everything in this slide, but each of you should look at the column that is most applicable for your industry and see the types of things that are actually being done using AI to transform those industries today. We're seeing a lot of early adopting on the consumer and health and finance spaces. Industrial, transport, and energy have been slower to adopt that, but they're certainly there and moving that forward. SAS is involved in many government-related contracts using data to provide for better, safer security, et cetera, smarter cities as we look at that. And again, there's literally no end of the places that AI can be applied, and the real challenge for you as practitioners in this space is to identify those things that matter most for you and your business, and that you have the necessary data to drive those decisions going forward. So one of the things that's very important for Intel as we look at our involvement in AI, and this aligns very strongly with SAS as well, is we want to help drive the AI breakthroughs by accelerating both the compute side of it, which is obvious as Intel is a manufacturer, but also the development phases, providing the tools, the infrastructure, the modeling approaches that have already been proved out to allow you to jumpstart your own efforts within that. We also think it's incredibly important to democratize access to AI by providing the tools, training, machinery to allow everyone the ability to use these tools to advance their causes going forward. And third is the area of helping guide how AI is used. There have been a lot of cases with machine learning where algorithms were implemented that, frankly, if you and I did them as individuals, would probably be illegal. We have to be very careful as we develop algorithms that we understand the social and legal aspects of them as well as we move forward. And so those are three areas that we concentrate on as we move forward in this space. So I want to talk a little bit about the evolution of analytics, because AI is just another piece of your analytics toolkit. We should all understand that it's not appropriate to use deep learning for every solution. There are a lot of things that can be handled simply with a regression analysis type algorithm, and we should use the thing that gives us the best answers and why. But we have been moving up this evolution of analytics as we look at things. We started out with mostly descriptive analytics, with hindsight, analyzing and figuring out what happened. And then diagnostics, and it's not only, okay, this is what happened, but why did that happen? How can we prevent it going forward? Let's have the foresight about what will happen and when. That obviously moved us into the area of predictive analytics, of saying, okay, we know that when an engine starts exhibiting these characteristics, it's likely to have a transmission failure in the next 5,000 miles. We should probably, bring that vehicle in for support, right? And to drive that type of thing, you've got to do a lot of simulation-driven analytics and decision-making, and actually have a mature data lake or source of data to drive that. Prescriptive analytics is the next, and then ultimately to the cognitive analytics, where we're using AI-type activities and human intervention to help drive the automated enterprise, to allow it to adjust to changing environmental characteristics and move forward. If you look on the right, you kind of see the technology and product decisions that go into building all these things up. And it's important to note that all of these things are, it is a building block. You can't skip some of these processes. You have to have data. Well, if you have to have data, you have to manage the data. How are you going to manage the data to provide that? How do you know what's been validated, what works, et cetera? So it's all part of building that overall analytics and AI infrastructure that can allow you to move forward. So this is a slide that's a particular favorite of mine because it's really important as practitioners in this space to understand we're changing paradigms and changing the way that we think to deal with problems in the analytic artificial intelligence space. And we started conventional algorithms. We basically apply known procedures to generate answers based on things. These are things we understand completely. It's the most effective and efficient way to solve a problem when we actually understand all the processes within it. You know, I know that when I add 2 plus 2, it equals 4. It always equals 4. I don't have to worry about that, right? So that's the conventional programming model, very procedural. Deep learning inverts that whole process. We know what the answer is. We don't know how to get there. You know, the classic, you know, teaching a machine to recognize a cat, we know what a cat is, okay? You know, it has 4 legs, it has 2 ears, a mouth, and a nose. Well, so does a dog. So that's not, obviously not enough there to tell that, so it doesn't apply. The conventional way of thinking about describing it doesn't work as well for us, whereas deep learning, where we can provide lots of data, these are cat pictures, and this is how and let the machine determine what those procedures are by that training methodology. So again, it's inverting the problem for us. As we move to neuromorphic computing, which is a different style of computational engine entirely that mimics more the way we understand that the brain works today, where multiple things are processing in parallel, but they're processing in unique ways, that things like the time that it takes for something to make a decision is an important part of the answer. And again, the idea there is that we've got many different procedures, and we're adapting the answer by reinforcing those procedures that give us the best answer. And even further in the future for us is the area of quantum computing, where, you know, candidly, this one's still mostly a mystery to me, with the idea of the answers are superimposed in space, and the problem in quantum computing is how do you select and measure the answer there. You know, Intel has been working with SAS on all of these, well, not quantum computing, across the board, and we'll continue to work with them as our partner to drive these type of things forward. But that's, you know, the environment that we're looking at. And again, it's going to be a mixture of these techniques that give the best result for you and driving AI within your business. So, and again, this was talked about a little bit earlier as well, is the idea that there are many approaches to AI, and they are complementary. You know, the classic machine learning, where we're doing random forests or those type of techniques. They're very good in certain areas. They're not so good in other areas. Machine learning happens to be very good when you have large, uniform, dense data sets. If you don't have that, then deep learning is probably not the right solution for you to apply to the problem. There's memory-based AI solutions which use a totally different type of techniques to associative memory type models to drive solutions. And then, you know, there's what we typically refer to as classical or the logic-based solutions. Again, if it's a well-understood process, that's the best answer for driving the things forward. And so your solution, as was mentioned earlier, you know, these things are custom. It's the problem that you're trying to solve within your business will be a mix of these type of different techniques to drive a complete solution, is what we see going forward. And again, you know, different models differ in their computational and infrastructure implications. Deep learning is very computationally intensive, requires a lot of data. Logic-based, not so much. You know, it's the same process. We run it through, and answer comes out at the end. Those type of things. So again, optimizing your mix of those is incredibly important as you move forward. So, kind of summing things up, machine and deep learning is definitely a portfolio solution. And the goal is to accelerate the time to solution. And, you know, you have to have data curation processes, data labeling, have multi-user collaboration, interactive systems as you go to building. Training models is incredibly important. How are you training it? Do you have an experimental system so that your data scientists can play with the data and develop models before they're actually used in production. How do you deploy things to production? Is it being executed on the edge or within your data center? All of these things are critically important to your solution, and again, vary with the solution. If I'm talking about a vehicle system, then yeah, I probably want it implemented on the vehicle because it's that model being interpreted there will give me the best results rather than, hey, the data center saying, hey, the truck's going to break down in the next 10 miles. That's not too helpful, right? So, so our goal and SAS's goal as well is to compress both the compute and labor-intensive part of this innovation cycle so that we can get to actually delivering production results in enterprise-grade solutions quickly. The advances here, AI has been not only a computational revolution, but it can be equivalent to the industrial revolution for us as we apply this in different spaces. The goals are there. The companies that do it and do it well will be the ones who survive in the future, and those who don't will not survive. So, kind of wrapping things up before we open this up for questions is AI is definitely the next big wave in computing. Like I said, a 12x growth from where they are today is what's expected over the next 2 years. It's already transforming industries across the board, from medical research to obviously the big online service providers. Yeah, today is the ideal time to start building it in. There are, you all have opportunities to start bringing AI solutions into your business processes and deliver real value. Intel, working with SAS, we can help you get there. We have a portfolio of solutions, everything from the hardware side that we enable to the software that SAS enables to allow you to quickly get to driving those business advantages. So with that, I'll turn it back over. I will open up for Q&A.
Wonderful. Thank you very much, Pat. Great presentation. And we will jump over to our Q. We want to begin Q&A now. And if you have questions, again, please use the Q&A panel to send in your questions. Instead of the chat panel, we want to make sure our panelists see your question. And we already have a few in the queue, so let's jump right to them. First question, I believe, is for you, Mary Beth. And this one is, discuss views on open source and how it plays within the analytics ecosystem. Did you hear that, Mary Beth? I want to make sure you may be muted on your end. Yeah, there you are.
Yeah, I think I was muted. From an open source perspective, at SAS with our platform, we are able to leverage transfer learning. So if you've created an open source model and want to bring it in to kind of leverage the breadth and depth of SAS analytics, we allow that. We have open APIs, et cetera, and there's a lot of benefits to open source. But being able to back that with a platform that covers the full analytics life cycle and provides stability with security and governance, et cetera, we are open to that. And then you can also build your deep learning models on the SAS platform as well, using traditional SAS code method and capabilities. So we embrace open source throughout the platform. And again, we enable transfer of models through transfer learning in our open APIs.
Wonderful. Thank you very much. Next question, and Pat, this one is for you. What are some of the roadblocks you're seeing around analytics adoption?
Yeah, so quality of data is the #1 roadblock that I see. People will have data, but it may not have been sanitized and cleaned up and tagged as to what it represents, et cetera. So that's #1 is, and if you've got a good handle on your data, you're ahead of the game. The other roadblocks that we see when it comes to implementing solutions, specifically around deep learning solutions, is that deep learning solutions don't describe how they came to the conclusion that they came to without a lot of digging by your data scientists, right? And that can be a roadblock. People want to understand the process of what went on to drive that conclusion. So we see reluctance to move some things into production because of the inability to describe what the decision is being made on. That's an area of very active research in the community, is to get algorithms to describe themselves across the board. But it's really, you know, the data quality and the access to data is the #1 barrier by far.
Excellent. Next one, and this one is also for you, Pat. What does AI mean to the business users, for example, engineers, researchers, analysts?
Wow, that's a tough one. It depends very much on the problem being applied to, right? So for one of the programs that Intel is actively involved with is something called Project Thorn, which is a anti-child pornography, child trafficking practice. And one of the things that we provide with them is a human-assisted image recognition system. So you can start with a picture of a child, and then it will comb a database of, you know, all this trafficking that's going on, looking for children that match that image. Now, obviously, children age, etc. So there's a lot that goes on to there above that. But what it does then is it provides a ranked list. So rather than somebody having to manually go through literally hundreds of thousands of images looking for this, it provides ones, well, we think these are the most likely matches. Which one do you think matches, right? So that's a type of application where that synergistic use of both human and machine intelligence greatly speeds up processes, et cetera. And that same technique can be used in lots of places, from radiology to you know, engineering looking for defects.
Great. Next question, and I think this may be for you, Mary Beth, but I'll throw it out there. How are image processing algorithms integrated with AI? Is it part of data extraction from an external source?
Well, the image processing algorithms are the AI. So if you think about, when we talk about deep learning, we're talking about the use of a neural network. And we get to deep learning from machine learning because we have an increase in data, increase in compute power, which means we can run bigger models with better algorithms. So we're talking about running those image processing algorithms. Our ability is, our capabilities around this and our ability to ingest images as another data set, and then we can provide a variety of analysis, such as like machine learning techniques. And then for deep learning, we're talking about that those techniques are neural networks. And historically, machine learning could do simple image analysis like edge detection and boundary boxes. But to do more complex analysis like facial detection, that leverages deep learning. And at that point, we're looking at images at a pixel and a depth level.
Excellent. Pat, let's have you take this next one. Given the current and predicted continued data deluge, potential landmines exist regarding privacy, security, and other ethical issues related to the collection and use of data. How do you see these ethical considerations affecting the growth of AI?
And that, first of all, it's absolutely a true statement. You know, as we have seen recently, particularly in Europe, there's been a very active, well, at least compared to the United States, increase in regulation around data, the proper use of data, and the securing of that data. That's definitely going to be a continuing area. There's actually an excellent book that covers this as part of what it talks about. It's the title of it is Weapons of Math Destruction, which deals with kind of the ethical realities of how we can use data, etc. And like I said, that's one of the reasons that the 3 areas that Intel is focusing on. One is, okay, how do we make sure that we are respectful of individual privacy rights, and we are doing things that are morally and legally correct with the data.
Great. Here's one more for you, Mary Beth. Where do you see AI making the biggest impact?
I think that the big early adopters are going to be the same industries that were our big data early adopters. So financial markets, retail, and in some cases, communications companies. But I think where it can make the biggest impact, it really depends on the industry and the use case, but the possibilities are massive. So whether we are talking about image processing and analysis to more quickly detect the presence of cancerous nodules, or improving things that we've had bias in, like education, and how so we can maybe tailor education for students on an individual basis and help teachers with different techniques based on performance of individual students. But then you've already seen many advances in the retail areas where you can recommend in real time the next best offer type of scenarios. We're seeing chatbots and analytics run on those in call centers to help understand voice of the customer better. And I mean, the opportunities really, I don't want to say that they're endless, but that there are many, and it really is industry specific. And it's kind of, what are those things that we haven't been able to do because there's so much data to get through and data intensive to get to a decision. And those are really going to be key areas where we can automate that insight discovery process with artificial intelligence, and then help get to what that next decision is that we as humans need to make, and really use AI to help us surface that information to inform those decisions.
Yeah, if I can jump in here, I think if you look at the idea of autonomous vehicles in particular, and how disruptive that can be to the trucking industry. I saw a recent study that said the most common job title across most states in America is truck driver. Well, if that's the case and we're dealing with autonomous trucks, that obviously has implications above and beyond just the logistic companies as far as the economy goes, et cetera. So, there's definitely going to be shifts and things that can be automated going forward. And, just look at the size of the automotive industry, and when you think about the revolution that can go on there with the idea that, okay, we don't actually have to drive these things anymore. What's that going to mean? I'm not smart enough to understand all the implications of it.
Well, wonderful. We're going to let that be the final word. Thanks to all of our attendees for joining us, and a big thanks to Mary Beth and Pat for their insights and great information. And before we conclude, we want to remind you that you can connect with SAS on social media, on Twitter, Facebook, YouTube, and LinkedIn. You can join and participate in the ever-growing SAS communities, which now has more than 120 members. Once again, thanks to everyone, and enjoy the rest of your day.